how costly is multigrid. And here, we are going to look at 1-dimension, 2-dimensional, and 3-dimensional problems. So this is the multigrid cycle we have performed. We perform a smoothing on the fine grid, right? So let's say the cost is proportional on a 1-dimensional grid. This is proportional to n, right? So let's say alpha n is the pre-smoothing on the fine grid, and interpolation cost is very similar to the smoothing iterations. It's basically proportional to the number of grid points, and this is proportional to n over 2 for a 1-dimensional grid. This is proportional to n over 4, and this is proportional to n over 8. And coming back, this is also n over 4, n over 2, and n, right? So one multigrid cycle is going to have a cost of a constant times n plus half n plus a fourth n plus n over 8. If you have more grids, it'll be n over 16, etc., etc. If you add all these up and you want to approximate it by something, what would it look like? It's n of 1 plus half plus a fourth plus eighth. Do you recognize this series? What's the summation of the series? About 2, right? So that's approximately twice the cost of only doing the fine grid iterations. If you don't go to the coarse grid, you just perform the iterations you would do on the fine grid, you would be saving only half of the computation cost. And if we only do these 10 Jacobi or Gauss-Seidel iterations on the finest grid, you probably see the solution not converging at all. Like you only get a few lines. So that's not the whole story yet. If you look at it on the 2-dimensional problem, so this is 1D. On the 2-dimensional problem, just like what we just solved, and imagine n is the total number of grid points on the finest grid. The series is different. So this is still n. When you go to a coarser grid, the grid is 4 times smaller, right? So n over 4 and n over 16, etc. So what we would get in the 2D is 1 over 4, 1 over 16 plus etc. Well, it's n times 1 over 1 minus 1/4. So that's about 4 over 3 times n. So this is only a little bit more expensive than doing this thing, doing only the fine grid operations, right? Okay, so furthermore, as you can imagine, if I go to 3D, that'll be even more cheaper. So the next grid is 1/8 as expensive, and the next one is 64 as expensive, and this is going to be 1 minus 1/8, and that'll be 8 over 7 times n. So again, a little bit more expensive than doing this only on the fine grid.